Hi dear students, welcome to Geeta's classes. In this class, we are going to revise the entire unit of Laplace transform, that is R22. It is in the subject Ode&Vc. So I am going to revise this using mind mapping. So main topic is Laplace transforms. And in this, mainly we have three major topics. One is Laplace transforms, one is inverse Laplace transform, one is Laplace transform, then inverse Laplace transforms, and we have solving the differential equation, solution of differential equations, ordinary differential equations using Laplace transform. So these are the main topics. Definite questions will come. Find the Laplace transform of functions and find the inverse Laplace transform of some functions and solve the differential equation using Laplace transform. These are the main topics. Now let us see Laplace transforms. In Laplace transforms, we have seen elementary functions. Laplace transform of elementary functions. All these are just topics, and I have explained all the theorems, all the topics with problems are available in the channel. You can go through. Okay, these are the main topics which we have to remember. Okay, which we have to study. So Laplace transform of elementary functions you have to study. Then Laplace transforms using first shifting theorem. Then you have second shifting theorem. So second shifting theorem is with unit step function. Okay, here you can say it is along with unit step function or Heaviside unit step function. And then we have Laplace transform of functions multiplied by t. Functions multiplied by t or t power n. Then we have seen Laplace transform of functions divided by t. Divided by t means it can be extended for t squared, etc. Okay. Then we have studied Laplace transform of derivatives. Also we have seen Laplace transform of integrals. All the topics with the problems are available in the channel. Please go through them. Okay. Next is evaluation of integrals. We have studied Laplace transform of derivatives and integrals and evaluation of integrals using Laplace transforms. Okay, then we have also seen change of scale property. And all these theorems you should be thorough with, so that inverse, if you are thorough with these topics, then only we can find out the inverse Laplace transforms. Also, we have also found out the Laplace transform of periodic functions. Okay. So these are the main topics in Laplace transforms. Okay. So this is the definition, basic definition. Basic definition is the function, Laplace transform of the function is defined for all the functions which are defined only for t greater than 0. Okay. And what is L of f of t? Integral 0 to infinity e power minus st, and whatever function you have to write here. f of t into dt. And we are transforming from the coordinate t to s. So variable t is transformed to s variable. So after finding the Laplace transform, you will not have t, it will be a function of s. So we will denote it, let us denote it by f bar of s. Okay. Next is piecewise continuous, that is even though the function is continuous, piecewise also we can find out the Laplace transform. That is that there is a sufficient condition. Next is function of exponential order. All the definitions are important, even for 2 marks, 1 mark question they can ask these definitions. So a function f of x is said to be exponential order if it satisfies this condition. Okay. Then sufficient conditions for the existence of Laplace transform of a function is it should be piecewise continuous and it should be of exponential order. And we have to you have to remember these functions, Laplace transform of the basic elementary functions. These are all elementary functions. This is L of f of t. It is integral 0 to t infinity e power minus st f of t dt. L of constant is k by s. L of 1 is 1 by s. L of e power at is 1 by s minus a, e power minus at is 1 by s plus a. L of cos at is s by s squared plus a squared. L of sin at is a by s squared plus a squared. Please remember, for s you will get constant, for s we will not have s. Okay, remember like that. So cos you will have s in the numerator. And L of cos h at is s by s squared minus a squared. And L of sin h at is a by s squared minus a squared. And L of t power n is n factorial by s power n plus 1 if n is an integer. Otherwise, if it can be reduced to 1 by 3 or 1, then gamma of n plus 1 by s power n plus 1. Depends on the n value, we have to write accordingly. So next is first shifting theorem. If you know L of f of t as f bar of s, if the function is multiplied by e power at or e power minus at, without this e power at or e power minus at, you find the Laplace transform. That is our L of f of t, and replace s by s minus a or s plus a accordingly. Okay. And if the and please remember, multiplication is always related to differentiation and division is always related to integration here. Okay. So L of t power n into f of t. So if it is multiplied by t power n, then minus 1 power n d power n by ds power n into f bar of s. That is, differentiate that many times. If you have, if t power n is multiplied n times, you have to differentiate. First, without this t power n, you find the Laplace transform and differentiate n times with respect to s and multiply by minus 1 power n. Okay, where f bar of s is L of f of t. Similarly, L of f of t, if it is divided by t, integral s to infinity f bar of s ds. So if it is multiplied by t squared, then you have to integrate twice. Integral s to infinity, integral s to infinity f bar of s into ds. Okay, twice you have to integrate. Next is Laplace transform of derivatives. This is very useful formula for solving the differential equation. So you have to remember L of f dash of t, L of f double dash of t, etc. L of nth dash, f of nth dash of t. Okay. And Laplace transform of integrals. Integrals means if it is integral 0 to t, without this you find out, that is f of t, L of f of t you have to find out, which is our f bar of s, and for integration you have to divide it by s. Already I have told you, differentiation always you relate it to multiplication of t, you relate it to differentiation, and division you relate it to integration. Okay, so here also integration means divided by s. Here multiplication, differentiation is multiplied by s, and so on. Okay, so similarly integral 0 to t, integral 0 to t, twice if you have, then 1 by s squared into f bar of s, and so on. That is, without this integration you find the Laplace transform of the integrand and divide it by s squared. Okay, if it is twice. Next is Laplace transform of periodic function. If it is a periodic function of period capital T, then L of f of t is equal to 1 by 1 minus e power minus s into the period. Whatever is the period, accordingly you write the period here. E power minus s into capital T integral 0 to capital T e power minus st f of t dt. Similarly, next is second shifting theorem. Second shifting theorem is related to the unit step function or Heaviside unit step function, or sometimes it will be defined as u of t minus a. In some book it will be given as Heaviside's unit step function, that is h of t minus a. Both are one and the same. Okay, it is defined as 1 if t is greater than or equal to a and 0 if t is less than a. Okay. And if you know that u of t minus a and if L of f of t is f bar of s, if the function f of t minus a is multiplied by u of t minus a, then you find the Laplace transform of f of t and multiply by e power minus as. Okay. Even the proofs are available in the channel. If you want, please go through them. All the theorems with the proofs are also important. You can be asked. Next is change of scale property. If you are changing the scale like this, if L of f of t is equal to f bar of s, if you change that variable t to at, then you have to divide. In the t domain, if you are multiplying with a, and you have to divide in the s domain. Okay. So 1 by a into f bar of s by e. This is the change of scale property. Next is inverse Laplace transform. Whatever we have studied in the Laplace transform, everything is applicable for inverse Laplace transform also. Okay. In the inverse Laplace transform also we have whatever we have studied in the Laplace transforms we will have here also. So first inverse Laplace transform is using partial fractions. And different types of partial fractions are there. Depending on the requirement, we will find out. Next is using first shifting theorem, we will find out inverse Laplace transform. Using first shifting theorem. Then inverse Laplace transform using second shifting theorem. Whatever we have studied in the Laplace transform, it is applicable here also. From that you can find out the inverse Laplace transform. Okay. Then using inverse Laplace transform of derivatives. Inverse Laplace transform of derivatives. Then inverse Laplace transform of integrals also we have studied. Then inverse Laplace transform using change of scale property. Using change of scale property. Whatever we have studied in Laplace transform, we have to use for inverse Laplace transform also. Also we have studied one special theorem called convolution theorem. If you have to find out the inverse Laplace transform of product of two functions, then we can use convolution theorem for finding the inverse Laplace transform. That is, you have to take the inverse Laplace transform separately and then you have to use the convolution of two functions. Okay, f1 of t and f2 of t, or f of t into g of t. Okay. So these are the inverse Laplace transform of standard functions. So please by heart these things, try to remember all these things. Actually it is very simple. If you have L of 1 is equal to 1 by s. If you are thorough with the Laplace transform, then it will be easy for inverse Laplace transform. If L of 1 is 1 by s, then L inverse of 1 by s is 1. Okay. Like that. E power at is 1 by s minus a. So L inverse of 1 by s minus a is e power at and so on. So try to remember these formulas also. Inverse Laplace transform of standard functions. These are again standard functions only, or elementary functions we say. And we have linearity property of Laplace transform and inverse Laplace transform also. So f1 bar of s, f2 bar of s, you multiply with the constants and you can take the constants outside. Okay. So next is convolution of two functions. This is the definition, convolution theorem. This is the theorem. I told you already. If you have if you want to find out the inverse Laplace transform of product of two functions, then find their inverse Laplace transform, that is f of t and g of t separately. Take the convolution product of f of t and g of t. Okay. Next is solving the differential equation. Solving the differential equations using Laplace transform. This is the last topic of this unit. Here, if you have a differential equation, first you take Laplace transform on both sides. That is the first step. On both sides. And the second step is you collect all the term of L of f of t or L of y. Laplace transform of L of y. You collect all these terms equal to a function of s. You have to write as a function of s. All the remaining function you bring it to the right hand side. So functions of s. Then take inverse Laplace transform. That is why you have to be thorough with the Laplace transform and inverse Laplace transform to solve the differential equation. Okay, by finding inverse Laplace transform, you will be getting y is equal to, okay, L inverse of y. It is a function of s, sorry. Y is equal to L inverse of, here if you will get some function of s, find the inverse inverse Laplace transform of this right hand side function, you will be getting y. Okay, this will be the solution. And I have done some problems in the part 1, part 2, part 3. Important questions I have dealt with. And in part 3, I have solved 5 or 6 problems I have solved differential equations. Okay, 5 or 6 problems are there in that. Please go through them. One definite question you will get from that inverse solving the differential equation also. Okay, you can expect one Laplace transform, inverse Laplace transform, and solve the differential equation using Laplace transform. Okay, hope this will be useful. Please go through the problems, please practice some problems, and all the best for your exam. So please give a like and share it with your friends so that it will be useful for them also. Thank you so much for listening.